Now we are discussing about concept of routers and routing packets in computer networks. Because we are dealing with the network layer, in the source side, the data from the previous layer in the form of the segments we are making in the form of the packets. The data will be traveling in the form of the packets. At the destination side, these packets will be again converted to segments. Now the router, it will take care to send these packets from the source host to destination host in the form of the datagrams. We have discussed the concept of datagrams previously. Two or more computer networks, by using internet, they are interconnected with the help of the router. So a router is needed to connect two or more computer networks. We already discussed internet means connecting two or more computer networks. Now the question comes, how these two or more computer networks are connecting? Definitely interconnection of two or more computer networks, we are calling this is internet. That is the network of networks. One network may be LAN, one network may be WAN, both may be LAN, both may be WAN, irrespective of the network topology. One network may work in the ring topology, one network may work in the mesh topology. So I have network 1 one side, network 2 one side. Irrespective of whether it is LAN or WAN or MAN, this is LAN, WAN or MAN, irrespective of its topology. Two different networks with different topologies or with different, whether it is LAN or WAN or MAN, I want to connect. So at that time, to connect these two networks, we are using the router. So it interconnects the two networks. So the combination is forming that internet. So router is very much useful for our internet. The router, it selects the best path to transmit the packets in the form of the datagrams. How it selects the best path? There might be, we call the concept of the routing table. It might be static or dynamic or default. So we have one table. Yesterday we discussed it. It will use an algorithm in the dynamic routing. So here in the static routing, the routing table will be updated manually. I will update the table. This is the path, this is the path, this is the path. Definitely there must be an admin to update this table because manually I have to add the addresses. This packet should go this destination. This packet should go this destination. That is static routing. In this static routing, the advantage is only admin knows where the packets will go. So it is adding the security. Definitely the security is the advantage. And there is no need of algorithms particularly to give the routing path. That's why it is cheaper. And we are already defining the path with the help of the administrator. Bandwidth usage is less. So no bandwidth gets wasted. And bandwidth of the router to router bandwidth is not required between router to routers because we are giving the path to it to go where to go. We are clearly defining. This is static, means it is not at all changing. But the disadvantage with the static routing is if an administrator changes, a new administrator, network administrator comes, then the problem will come. The new network administrator does not know from what network to what network he defined the path. What is the destination network, whether it is using which topology, and whether it is LAN or WAN, it is difficult for him to identify because he is not familiarized with the computer networks. So that is the disadvantage, and it will not work for the large networks. Okay, he can define the routes for some smaller networks. If the networks are in the form of the thousands of networks, that will become hectic for him. That will become hectic for any man, any network administrator. So in that time, we have two more options, default routing. Default routing means we are fixing the path. Whatever may be the packet coming from whatever may be, whether it is coming from LAN or MAN or WAN, whether it is coming from the mesh topology oriented network or a ring or a mesh or hybrid or a tree, whatever may be the packet coming, we are forwarding the packet to a fixed router. So router 1 to router 2, the path is fixed, default. Irrespective of where the packet is coming, irrespective from where that packet should go, this path is fixed. Even though the destination is changing, the source is changing, the network topologies are changing, but from where the packet is coming to this router and where the packet is going to the destination, that is does not need to this router. Only after receiving the packets, just it will give a hand to next router, take this packet. This is called as default routing. Single route is there. Definitely bandwidth is not required. This is the advantage. Now we are discussing about dynamic routing. Here we use this concept of the routing table. We have some predefined fixed paths, and based on adding nodes, these paths can be added later also. Here the routing path will be decided automatically based on the network traffic. Example, from router 1 to router 2, router 3. Sometimes the packet may go from router 1 to 3 or router 1 to 2 or router 1 to 4. The path is dynamically changing based on the traffic, and if there is any error in any link, it will try to avoid that path. So paths are sometimes more traffic is there towards one destination, then we will use the different paths. The same router, it has to send to the same destination, but simultaneously 4 packets came from the 4 sources. Then it will use the 4 routes. So the paths are different. The paths will be decided automatically. No manual intervention is required for defining the path. That's why this is called as dynamic routing. So when we are saying automatically the paths are defined, when we are saying automatically this is selecting the best transmission path, it is an intelligent device. Router is selecting the best transmission path. Definitely it has a memory. Definitely it has a CPU. And along with that, to decide it, we require protocol. Those protocols we are using here are RIP, Router Information Protocol, and Open Shortest Path First. Open Shortest Path First means it will try to, this protocol will try to understand what is the shortest path. So you open this path first. If the shortest path is already being used by another, then go for the next one. Open shortest path first means give the way with the shortest path. Yesterday we discussed path means we do not measure in meters or centimeters or kilometers. We measure in the form of the how many links are connected. So by using that one. Router information protocol means here the router will send the information. The second router is in this much distance to you. The third router is this much distance to you. Based on that, we are sending the data packets. So whether it is best to go send this data for the second router or third router. By using these protocols, we are selecting the path. In this path only, the packets will be transmitted. So here, Address of the computer, when we are defining address of the computer means destination or source, we will have network ID and node ID. This network ID, node ID, whatever we are mentioning, this address will be stored in the NIC, network interface card. If a router is having two NICs, means we can connect two networks to it simultaneously. It can connect to two networks. If a router is having three NICs, it means we can connect three computer networks to the router. So whenever we are connecting a network to the router, the network address will be there in the NIC of that router. Example here, this is network A, this is network B. Now this router definitely it will have two NICs. One network interface card will store the network address of A, and the second network interface card will store the network address of B. So these two network interface cards, they are storing two addresses of two networks, network A and network B. It is not relevant to me to know whether network A is LAN or WAN or MAN, or network B is LAN or WAN or MAN. The connection may happen from LAN to LAN, or LAN to MAN, or LAN to WAN, or WAN to LAN, or WAN to WAN. Generally we do not use MAN, medium area network, much. We use only either local area network or wide area network. So LAN to LAN, or LAN to WAN, or WAN to LAN, or WAN to WAN. And the topology of network A might be mesh topology, ring or star or hybrid or mesh. The topology of network B may vary. Example, in network A, I may use the ring topology. In network B, I may use some other topology. So here we are connecting these two networks to the router, means the router should have definitely two network interface cards to store the address. The packet is coming from A and the packet should go the B, network B. From that network it will reach the destination, that is the secondary case. But now we are discussing from network A to network B the packets are going. So when we are sending the packets, the sending host, whatever the host is there, it will forward the packets. It will forward the packets to this router, and this is the choice of the router to select the path. Which path I have to take to reach the destination. So the path will be selected by the router based on different types of the routing we discussed, either static or default or dynamic. Generally we use dynamic routing only in most possible cases. It is difficult to define the routing table manually unless you have very good knowledge on the network addressing. So this is the concept of routers and routing packets in computer networks. Here we are transmitting the packets from network A to network B. For that we require the router. Without router, can't we send from network A to network B? Without router, when we are sending the data from device 2 to device 100, the path in which we have to send, that path will not be defined. So the name itself, it tells, it gives the route. It is the one who is giving the route. Without the router, if we send, example we define a predefined route between D2 to 100. What is the guarantee every time D2 only will send the data to 100? This time D3 wants to communicate. That time definitely the data will collide with the D2 data. So that's why we require an intelligent device. N number of devices might be want to communicate with the D100. Example, Google server. N number of users want to communicate with the Google server every day. The packet transmission should be done with the different routes with the intelligent device called a router. So that's why we are saying a router we need definitely when we want to connect one computer network to the second computer network for the transmission of the packets.